Oh, welcome back. So now here we are, we're in Module 2. And in Module 2, we're going to dig deeper into what you read in Module 1. So if you look back in Module 1, you learned about, in the reading, the history of AI and the fact that AI's been around since the 1950s. And with recent innovations in hardware and technology, it's advanced AI to a point that many didn't expect us to be where we are today. Now, back 70 years ago, there's something that was said that was called Moore's Law, that the capacity of computing would double about every 2 years or so, 2.5 years. And that held true. If you had a computer, within about 2 years, it was only half as fast as the new stuff on the market. It held true for only so long, because where we're at today and how fast technology is growing, expanding, and evolving, it's much faster than doubling every 2 years or so. So when we think about that, we looked at that in the context of a car and fuel economy. Could you imagine that you had a car today that got 30 miles to the gallon, and 2 years from now, it got 60 miles to the gallon, and 2 years later, it got 120 miles to the gallon? That's what technology has done, and that's what's allowed us, in conjunction with all these new sensors that keep track of our thermostat in our house. I've got sensors on fish tanks that keep track of temperature and chemical balance, and the spectrum of light at any given point. Now, these powerful processors have allowed us to have transactions within the computer happen far faster than what had taken place in the past. So in this module, we're going to go back and do tasks associated with what you read in that first lesson. So you'll have another LinkedIn Learning group of videos. It's about 29 videos. They're all very short. I think the whole thing altogether is about an hour and a half. You'll take another quiz that is directly related to the foundation of AI, but it's also building upon that, looking at the big picture of AI and what AI is. So now, let's jump down into what we've got going on. So, the course learning outcome for this lesson is describing the history of AI. We're going to cover a whole lot more than that. So, we're going to define AI, the history of AI, technical approaches to AI, but then we're going to get into what is supervised and unsupervised AI. We're digging into what AI is and how we use AI now in this module. Okay. We're not just dealing with digital literacy. Now we're digging into AI. Now, I'm not going to cover things that we dealt with last lesson, such as the time map, supplemental lectures, accessing the reading, the resources, tips, tricks, and insights. This quiz is directly related to another LinkedIn Learning resource, and this one is the foundations of AI, okay, or an introduction to AI. Now, we've got another reflection, and you dealt with the last one. It'll be the exact same interaction each lesson. Your responses will likely change as the difficulty changes, the amount of time changes, the resources you've come up with to help yourself and others. Okay. So, with that said, let's go jump into the reading. What's new for lesson 2. Now, in lesson 2, we've already got a foundation of what digital literacy is, how we use data in our day-to-day lives, how long AI's been around, and what AI is. Now we're dealing with the resources that are required for AI to do what it needs to do. Now, I talked about Moore's Law and the fact that the capacity of computing is evolving at such a fast rate. We need to look at data, what data is, and how it's important to us, and how the computer works, and how that's important to us. Now, the computers that we're dealing with have specific components that are much like you working at your desk in your office or your desk in your home. If you're sitting at your desk, the one doing the work, processing what comes and goes, that's the processor, or that's you. You're doing the work, handling the transactions as they come and go. Let's say that you have a tray on your desk that handles all paperwork that you need to deal with today while you're doing your work. But at the end of the day, you need to make sure that tray is empty because everything done for the day is done, and either we're going to get rid of what we don't need or we're going to file it away. That tray is analogous to our RAM, random access memory, in the computer. So the processor is the person working. RAM is that short-term volatile memory that if we're not careful, if we have a power fluctuation, whatever's in there can disappear. Those two things are very important to what's taking place in the evolution of AI and how we deal with data. So in AI, we've got a concept that's called data science or data analytics. Let's start off with data science. And data science is our ability to take data, evaluate it, and derive information from it. You say, well, what's the difference between data and information? A lot of people look at them as they're the same. They're not exactly the same. Data is something that we've collected that is not necessarily in a context. It doesn't really mean anything. Now, let's say 458. That's a piece of data. And it's not until we put that piece of data in some context that it becomes information. 458. That's Jim's employee ID. Now it becomes information. If I asked a system a question and say, what is Jim's employee ID? And it returns that information to me, 458. Well, it just went and got that data and it said, here it is. When it was being stored, it didn't mean anything. It was just 458. When it was being delivered to us as information put in some context, 458 meant something. That's Jim's employee ID. So there's the difference between data and information. Right? They are very similar, but it's all about the context. So we collect data on a day-to-day basis. Data about you and everything you do is being collected on a day-to-day basis. Almost every hour. And I don't mean to say that in some kind of conspiracy theorist or, oh, you got to be careful. That's not the point here. The point is that data is being collected by sensors everywhere we go. Just about. Now, if you're off-grid, There may not be much data being collected about you, but that doesn't mean there's no data being collected about you at that point in time. When we're driving down the road, data's being collected about us. Your transaction with your SunPass, you're driving in a specific lane on the Turnpike or I-95. Your license plate is being captured in an image. The system then uses AI to determine the value of the characters in that license plate and then relate that to some database somewhere to find out whose car is that. So AI is able to do that. So we look back and we say, well, data is the database that has everybody's license plate number in it, and everybody's name and everybody's addresses. All that data is collected. When we put it in a context, that's Jim driving down the road. Send him a bill. He's got a toll, he's got to pay for that bridge or that one special road to get from here to there. That's what AI has allowed us to do. Instead of having somebody standing at a toll booth and saying, here's your ticket, and then at the end of that toll road, which the Turnpike is, somebody else would be standing there saying, let me see your ticket. You owe us this much money. Hand us the money. Artificial intelligence is what has replaced the person in that mechanism. Now, I don't mean to say that in a way that AI is replacing people. AI is far more efficient at doing that task. People make mistakes. People lose their tickets. With this, as it stands, an image is taken, we know whose vehicle it is, we'll send them a bill. So this data is processed by a computer to derive information, and then decisions are made based on that. Now, in years past, artificial intelligence, let me back up. In years past, computer programming was such that we had an individual that said, I'm going to write a program to do this. And we wrote a program to display your name at a billboard. Computer program did that. Today, we're writing computer programs that tell us what factors or features in a given scenario are likely to cause disease, failure to a system, whatever it may be. So instead of us saying, here's the rules, process it, and yield an outcome, now we're saying, here's the data, tell us what's important. Instead of us deciding what's important, we have a computer going through, running all the calculations, all the permutations of the data, and it determines much faster than we could by hand or using our minds what's important in a scenario. Now, one of the things that comes into play at this point in the game is computer bias. We'll talk about it more in the course, but we think about what is bias. Bias means that we favor one over another for whatever reason. It may not be intentional, but there's some kind of preference or bias against or for some individual. Now, in computers, when we look at programming, who wrote the programming? A human. Humans are notorious for having bias, and a lot of times they don't realize they have the bias. When those AI programs were written, bias were built in unknowingly. They could be built in how it's coded. They could be built in on the data that's provided. I say, well, what kind of bias is he talking about? Well, if I went in and used, let's say, some form of AI that I said, create an image of a programmer, and it provided a AI generated image of a programmer. Well, it would have to have some context to determine what a programmer would look like. And if all the images it had related to programmers were of white men, odds are that it's going to provide an image of a white man as a computer programmer. It lacked sufficient data to give an unbiased result. So we've got to be careful with what we do. And like I said, we'll talk more about that as we move forward. But at this point, we've got these massive databases. And data is stored in specific units. And we see megabyte, gigabyte, terabyte, petabyte. This is how big data is. I think back when I was first in college, a megabyte was a big deal. A terabyte and a petabyte were unheard of. These were only things that major corporations had, and they cost hundreds of thousands of dollars. And now here I am today, and I've got a terabyte thumb drive in my pocket. Moore's Law. Things have changed that fast. Okay. Now, as we go through, we've got different types of data, whether it's social security number, addresses, but when we look at it, it's just numbers being stored. That's data. What's Jim's social security number? That's information. We retrieve the data about Jim. Now that's information. And we've got a number of systems within business that use data to make informed decisions. In business, I want to be competitive. I don't want to be the one that nobody comes to do business with. We're in business to make money. So having the best data available to me and being able to process it quickly and accurately will help me remain competitive. Now, we've got structured data, and that's the kinds of things that we were talking about here, where we look at it, we understand what it is. And unstructured data may be videos, recordings, or things like that, satellite images. Not a lot of structure to them. They may not be similar from one to another. So we've got data that's structured or unstructured, and we're going to jump in when we're dealing with that LinkedIn Learning for Quiz 2. You're going to deal with supervised and unsupervised. Supervised, we tell it the rules. Unsupervised, we say, look, we don't know what the rules are, but here's the data. Tell me what the rules are. Right? We'll deal with things like that using AI. But in this context, we're dealing with the data itself and the different types of data and how we store it. So we've got databases that store data about you. Now, you may not realize it, but one of the biggest things that identifies you is your phone number. And oddly enough, many of you, that phone number is not in your name. It's registered in a relative's name, parent, what have you. So that number is tied to your actions and your name. It's also tied to somebody else's name. Those actions are indirectly potentially tied to somebody else, because that phone number is what we call a unique identifier. No two people have the same phone number. Two people may have the exact same name. They may have the exact same birthday, but they're not going to have the same social security number. They're not going to have the same driver's license number. They're not going to have the same phone number. Those are unique identifiers. Those unique identifiers are very important in data and databases, because those can potentially link data from multiple data sources or different databases together. So data is collected about you relative to your banking. It's tied to your social security number. It may have your phone number in there as well. When you have transactions at a store, your name is on the card. The card may also have other information in there about you. Could have your phone number. We never know what's being stored on that credit card or debit card relative to information about you. But there is information on that card about you. That's why when you go perform a transaction, use your debit card or credit card, you're passing them data that has your account number, your credit card or debit card number, and your name on the front of the card. And also stored on the card is more data. And then a lot of times you'll look at your receipt and there's your name. Well, did they read the card? Yeah, they read the data that was on the card, processed it. That's how they're able to market to you. That's how a lot of marketing is taking place today, is these relationships. So in databases, we'll have one-to-one relationships, one-to-many, and many-to-many. And these deal with those unique identifiers. We call them primary keys, and there'll be a foreign key in another table where the data is being stored. Now, data is stored, and now we've got so much data that we also call it big data, because we've got these massive databases. And many of you have heard of the different iterations of ChatGPT. And we'll talk more about that in a future module. But ChatGPT is a large language model that allows us to interact using AI as a front end to process big data on the back end. And the different iterations of ChatGPT equate to the amount of data being fed to it. We'll talk more about this as we move forward. Ethical issues when it comes to those concepts and that data. Now, when we look at, when it comes to business, getting an understanding, we'll look at the business as an understanding. It has to understand the data itself. We got to prepare the data. We model the data. We evaluate what we've got, and then we deploy it. And that's the process that they'll go through in this chapter. They'll at least go through the first three. Now, in business, I want to know, and I think back to, I've got a degree in business, and I think back to when I was working on my MBA, we had to do a marketing was a marketing class. We did a marketing exercise. And you had products that you had to sell, and you had to set a price point and how many units you were going to produce. And there was a cost associated with production, and you had to have a certain profit margin. And we had to go through, and based on what data we had, we determined what our price was going to be, our price point, how much we were going to spend on marketing. And those decisions were based on our competition, because we wanted to be competitive in the market. And how current that data was dictated how accurate our responses would be, or how effective our responses would be. Now, everybody was being very reactionary in that scenario. And it wasn't just us doing it. Everybody had their own competing business. So my decisions impacted, my past decisions impacted what decisions others would make. And we have to have an understanding of how price will impact our sales. What's a trend when it comes to price? How impactful are digital ads on our sales, our marketing? Right? All those things come into play. So the business has to understand all that. We need to collect data about it. We need to go through and perform the analysis of it. Now we've got AI being able to do that, but we don't have just the external data. We've got data in-house that tells us about what we're doing. There's data that we can get from exterior sources. There's data that I can get from a third party. They will go get marketing data for me. So open source, I go get it, and it's freely available to me. Third party, I'll pay somebody to go get it for me. And this other one is data that I automatically have access to based on my internal systems. Now, I'm only effective to the point that my data is accurate and will support my decisions. So, in that scenario I gave where we're producing a product and it's all about the marketing and price points and all of that, if the data that I was going off of was a year old, I'm not going to be very effective. I need to know the data is current. I need to know that the data is formatted correctly. So we've got to go through, we may talk about it later on in the course, but there's a concept called data wrangling. And essentially, what that means is we're preparing the data so that the system can effectively utilize it. Because our data may be coming from, we saw above, multiple different sources. Now, my current research is in cancer diagnosis and analyzing different digital images. Now let's say hypothetically I've got 100 different doctors that are all using their personal cameras to capture the image. What do you think? Is there going to be a standard in the quality of the image, in the lighting, how it's being taken, how the image is being captured? With that, my data, if I'm using all of those images, it's not going to be uniform. Some of it may not be of a quality that I can even use. May not all be in the same format. I may have to convert some of the images into a different format. What if one's in black and white and the others are in color? Does that matter? Yes, it does matter, depending on how we're going about it. So we've got to go through a lot of data preparation. We get the data, make sure that I don't have duplicates, things that were just outliers where somebody, they just typed in something that didn't mean anything. I want to make sure that all the data is the way that it's supposed to be. I may do what's called as one-hot encoding. Man, what's he mean by that? Well, essentially what that means is I replace words with numbers. Describe the weather. It's muggy, it's hot, it's cold. We'll then take those words and replace those words with numbers. 1, 2, 3, 4, 5. Apple, pineapple, orange. 1, 2, 3. Right? That's what we call as one-hot encoding. By doing that, the computer wants to deal with numbers, not words, not descriptions. From there, we're preparing the data, making sure that the data exists in a format that the system will be able to interact with it, will be able to work with it. Okay. Now, I talked about bias, and like I said, we'll talk more about it as we move forward, but I think back to one of the professors had like a little boot camp to show folks how to do web scraping. It's a programming in Python traditionally where we use the computer to go interact with different web pages to capture data, get information from different websites. We call it web scraping. Now, it's said that depending on how you go about it, it's potentially illegal or unethical because you may have used credentials to access that data or access that website that did not permit you to do what you were actually doing there, but you went and got the data anyway. Now, there's all these data breaches where people have gone and hacked into systems. Just this morning, as I'm recording this, on the news was an AT&T breach of a few years ago. All the users, text messages, and who they interacted with, all that data was hacked. Now, they don't feel that data is all public, but it's breached or it's been compromised. What could somebody use with that data? We just don't know. But there are folks out there that are trying to capture data that they can manipulate or use either to control other people or to make money, depending on what it is, what their intent is. Now, how much data do I need for AI? I'm one to believe that the more the better. If I have a system that can process it, great. But the more data I have, and if my system can't handle that amount of data, I think back to a task that I had in a grad school course that I was in. And the professor said, here, tell me what you're going to do in your project. I said, well, here's what I'm going to do. Here's the algorithm I'm going to use, and I'm going to sequence DNA, and here's how I'm going to go about it. And she says, let me know how that works out for you. And I kind of got the vibe she was throwing with the way she said it. Like there was a little bit of sarcastic in there. Yeah, you're got to find out the hard way. And I did. Because ultimately, the system that I was using to perform that task was not robust enough, did not have enough of a processor, did not have sufficient RAM to do what I wanted to do in my lifetime. It could do it, but it was going to take about 68 years to do it. And I'm not going to be around that long. So the capacity of computing that I talked about in the onset has doubled, has doubled, has doubled. A couple years from now, it may only take 30 years. A couple years later, they may get it down to 10, 8 years. How fast we go about things, we're able to get work done a lot faster. So I want to have all the data that I can so that I'm well informed. I want to have good quality data that's not biased, that's not corrupt, that my system can work with. It's in the right format. I can access it quickly and efficiently. So that's the brunt of what we've got in dealing with data. Okay. So as we move forward, everything that you're doing for the next few weeks relative to this course, think about what data is being collected about you. What data do you collect? What data do you willingly share? What data are you sharing and not realizing that you had been sharing it? What data is important to you? Your grades? What assignments are due and when? All these things come into play. Okay? So with that said, we'll see you in the next lesson. Take your time going through the videos associated with that Module 2 quiz so that you're successful on the measure for that second course learning outcome in course learning outcome number 1. And we'll see you in the next lesson.